this lesson, your students will perform an experiment to illustrate, using a line graph, how energy is transferred when going uphill on a bike. To complete this lesson, your students will build and program a smart bike. They'll explore the transfer of energy as the bike moves across a flat surface and up a slope. They'll graph the motor's power consumption and the angle of the slope, then draw conclusions about energy transfer in a system. To prepare for this lesson, take a look at the This is Uphill lesson in the LEGO Education Spike app, or watch the following videos. He's looking cool on this bike, but it's getting kind of boring. What else could he do? What if he changed the resistance? It's like he's going uphill. Could he keep the same speed? What would he have to do differently? Let's build a smart bike that uses a motor for propulsion. You can build this one, or create your own design. So how does it work? The hub will show us in the line graph the angle of the slope as the bike goes uphill. The back motor will move the bike forward. You'll need to log power consumption information from that motor. The other motor? Well, in this case, it's just for fun. Okay, now that you've built your smart bike, it's time to try it out. Use this program. We're going to graph two values at the same time, the angle of the hub and the power of the motor. Test your program on a flat surface to start. Return to your device. To analyze the recorded values, look at the graph. What does your graph look like? Can you see a trend in your data? Are you ready to go uphill? You can use the box lid from your set to help create an incline. Place your smart bike about 1 meter from the bottom of the incline. What do you think will happen to the bike's power when it goes uphill? Press play to start your program and see if you were right. Great work! Now that you've mastered the basics, it's time for a real challenge. Make a path that looks like one you would take on a morning bike ride. Include up and down inclines and flat surfaces. Before you press play, think about what the graph angle variation and power variation will look like over time. Predict how the power will look in relation to the bike's angle. To take your skills to the next level, design your own smart vehicle that can drive uphill using a motor. It could be a car, a train, or anything you can imagine. Let's explore math using your smart bike. Look at the two values you've graphed during this lesson, the hub angle and the motor power. They've both been traced over time. Use digital tools or manually convert these values to trace a graph of the motor's power consumption over the angle of the slope. Now let's explore language arts using your smart bike. Write a science inquiry journal describing your hypothesis and conclusions, just like a scientist would. Or write a newspaper article reporting a major new scientific discovery, just like a real journalist. Find a classmate who's done the opposite assignment and compare your documents. If you've written both assignments, compare your documents. How are they similar and different? Ooh, that was definitely uphill.